Today we're going to be talking about how to describe a surface in three-dimensional coordinate space. We represent three-dimensional coordinate space with this r cubed symbol here a lot of times. It means that we're dealing with three-dimensional coordinate space where we have three variables and three coordinate axes, x, y, and z. I've drawn a three-dimensional coordinate system based on the right-hand rule here. And in this particular video, what we're going to be doing is describing the region defined by the equation x plus y is equal to 2. Now, the first thing we need to realize about this equation is that there's no z variable involved. We only have x and y. There's no z variable. What that tells us right away is that this equation represents a region that will never intersect the z-axis. When there's no z variable involved, we can't intersect the z-axis. Similarly, if we had, for example, x plus z equals 2, and there was no y variable involved, we would know that we were dealing with a region that would never intersect the y-axis. So that's one quick tip when you have an equation like this to recognize which variables are involved in the equation, and therefore which coordinate axes the equation will intersect, or the region will intersect. So in this case, we're only going to intersect the x and y axes. What we can do is convert this equation. Let's go ahead and solve it for y. We'll do that by subtracting x from both sides, and we'll get y is equal to 2 minus x. What we can do now is find the points at which this region will intersect the x-axis and y-axis. The way that we're going to do it is by putting in 0 for the opposite variable. So for example, if we want to find out where this region is going to intersect the x-axis, we're going to plug 0 in for y, because of course whenever y is equal to 0, we're along the x-axis here because there's no z variable involved. So it is that simple. So what we want to do is plug in 0 for y. We'll get 0 is equal to 2 minus x. Adding x to both sides, we'll get x equals 2. So what that tells us is that at x equals 2, and let's say that this is x equals 2 right here, our region is going to intersect the x-axis. So that's going to be a point on our plane. And we know that we are dealing with a plane because we only have two variables here in three-dimensional coordinate space. Because we have two variables, we're dealing with a plane. If we had three variables, we'd be dealing with a three-dimensional object, but in this case, we're just dealing with the plane. Now, if we want to figure out where it intersects the y-axis, all we want to do is plug in 0 for x. When we do that, we'll get y is equal to 2 minus 0, or just y is equal to 2. So what that tells us is that at y equals 2, and let's say that that's about here, it's going to intersect the y-axis. Now, because we know that our equation x plus y equals 2 is never going to intersect the z-axis, but it intersects these 2 points and we have a plane, we immediately know that our plane is going to be the plane that connects these 2 points here, and we can try to draw it like this. We'll draw two lines parallel to the z-axis here. We want them perfectly parallel to the z-axis because we know that our plane will never intersect the z-axis, and then we can draw it like this. And now this is just a representation of the plane here, but basically you could shade it in like this if you wanted to. And if we wanted to describe this verbally, or if we wanted to write out a description of this plane, what we could say is that it's a perfectly vertical plane. We know it's perfectly vertical because it's never going to intersect the z-axis. If it were tilted at all, it would intersect the z-axis at some point, but it's going to be a perfectly vertical plane. It intersects the xy plane. Remember that our xy plane here is this plane here. It's the floor of our three-dimensional coordinate system that includes the x and y axis but not the z-axis. This is our xy plane here. We know that our region is going to intersect the xy plane along the line y equals 2 minus x. So this line right here that lies in the xy coordinate plane, this line right here, like this, that line is defined by y equals 2 minus x. You could also write it as x plus y equals 2, either way, but that's what that line is. This line right here is no different than in an xy coordinate plane like this, a two-dimensional coordinate plane where we have x and y, only two variables. We have y equals 2 minus x. That's this line right here. So it's just translated into 3 dimensions, but it's essentially this line like so. So that's how we get a picture of it together, and we can just call it the perfectly vertical plane that intersects the xy plane in the line y equals 2 minus x.